Hello dear students, this is Dr. Pramod P, Professor EC Department, LBS College of Engineering, Kasargod, and today we are going to discuss an important and interesting topic, and it is modern digital design flow. Let's at first see what's the meaning of a digital design flow, and it's basically a structured systematic approach to designing digital systems, particularly integrated circuits and digital products like websites and applications. To define the design at different levels of abstraction, it leverages CAD, that is computer aided design, and CAE, that is computer aided engineering tools. And primarily it uses hardware description languages like Verilog, HDL, and VHDL. Now let's see exactly what is done in this digital design flow. The process involved in performing smaller design or the design of a fully contained subsystem or even the entire system can be broken down into individual steps as shown in the figure. This particular figure represents the generic digital design flow, and it actually consists of, it starts with basically specifications, functional design. In the first step, that is specifications, one should state the desired behavior of the design using broad high level specifications. The second step is the functional design, and in that one should describe the high level architecture of the design. Just for an example, block diagrams for input or output, then subsystems, and generic behavior such as truth tables, state diagrams, and algorithms. The third step is synthesis, and it's about creating the gate level connection, schematic or netlist of the design using logic synthesis processes. Just for an example, KMap, Karnos map, or automated CAD tools can be used in this regard. The fourth one is technology mapping. In this particular step, we need to select logic technology that will achieve the already mentioned specifications for the system. Just for an example, a 32 nanometer CMOS ASIC design. Now the gate level netlist or schematic should be manipulated into a form that is suitable for the technology used. The fifth step, that is place and route, is about arranging the components to minimize the area needed on a particular board or chip, and wire all connections to minimize the interconnect length and crossings. So the next step is verification, and verification here refers to the estimation of whether the final design meets the timing and power consumption requirements of the original specifications. Once the design is verified, it can be implemented, and this is known as fabrication. The implementation can be performed in the form of ASIC, that is application specific integrated circuit, or programmable devices can be used, or board level implementation can be done. Generic process design flow discussed so far can be applied across classical and modern digital design flow. Let's discuss now the classical digital design flow with a suitable example. So the first step we have is the specifications. Let's have the understanding of classical digital design flow with a suitable example, and the example over here is designing of a prime number detector. So as far as the first step is concerned, that is specifications is concerned, it's about to design a prime number detector that takes in values from 0 to 7. The circuit should be able to indicate a prime number with a delay of less than 200 ns. That's our specification. So in the second step, that is functional design, we have represented over here an entity diagram or a symbolic diagram that represents the input combinations ABC over here, an example, and PN at the output section, and it is also represented, its functionality is also represented in terms of truth table. ABC are the inputs as shown over there, and if it is a prime number, then the corresponding combinations are 0 1 0, then 0 1 1, then we have a 1 0 1, and finally 1 1 1. The third step is synthesis, that's about getting a net list, that is the components used and their interconnections should be obtained from this step, and as shown over there, K-map or Karnaugh map is used over here to indicate the reduction process. Then resulting circuit is shown over there, gate level circuit is shown over there towards the right side. The fourth step is technology mapping, that is we got now the net list, and the net list has to be manipulated so that it will be suitable for the technology used. 74HC logic family is used over here since it's the most cost effective technology for this particular design. Here NAND gate only implementation used for minimizing the area used. The fifth step is place and route, and in this particular step the circuit to be implemented is placed in a floor plan and an estimate of interconnections are made. The sixth step is verification, and based on the layout the wire delays are found. The delays of gates are taken from the data sheet, and the final step is fabrication, and in fabrication step it is implemented in a particular hardware. In comparison with the classical digital design, the modern digital design allows additional verification at each stage using automated CAD tools. The modern digital design flow is shown over here now. The specifications as usually is the first step. After the specifications are finalized, then the functional design, and here compared to the previous flow, that is classical flow, we have a verification also. Here simulation is performed to verify the proper functionality, and if found fault, then once again checking is done, functional design is done, and simulation is done till it get corrected. And once it got corrected, we will be moving to synthesis step, and in this synthesis step also logical simulation is used to verify the functionality of gate level logic. Then if it's found incorrect, we will be doing it once again, the synthesis process. If found correct, moving to the next step, that is technology mapping, and in the technology mapping we need to manipulate the gate level net list. Then once it's suited for the technology, then simulation is also done to ensure the timing requirements are met properly, and if it's not, then once again it is done. Otherwise if it is correct, we will be moving on to place and route step, and once it is here also simulation is done, and once simulation is correct, we will move on to the next step, and in this particular step, which is verification, we will analyze the final design to see whether it meets the original design specifications. And the seventh step or the final step is fabrication. In this particular step, the particular design is implemented in the required platform, maybe an ASIC or programmable platform. Thank you all for watching this video. Have a very nice day.